Hello everyone, this is the challenge question walkthrough for Edexcel's Applied Year 1 textbook, and this is the third part in the series for AS Mechanics, and we're going through the challenge questions in chapter 11. Okay, our first question is from exercise 11D. The motion of a robotic arm moving along a straight track is modelled using the equations v equals t squared over 2 plus 2, for 0 is less than or equal to t is less than or equal to k, and v equals 10 plus t over 3 minus t squared over 12, for k is less than or equal to t is less than or equal to 10. The diagram shows a sketch of the velocity time graph of the motion of the arm. Work out the total distance travelled by the robotic arm. So we are looking for the distance underneath the curve, so that is this area here. And to do that, it would probably be a good idea to find the value of k, so we know what limits we're integrating from. So the point k on the graph, k here, where the two different quadratics meet, and we know that here y will be the same for both of these quadratics. So we can say that for t equals k, we know that the two velocities will be equal, and therefore we have k squared over 2 plus 2 is equal to 10 plus k over 3 minus squared over 12. Multiplying everything through by 12, we get 6k squared plus 24 is equal to 120 plus 4k minus k squared. And taking everything onto the left hand side, we have 7k squared minus 4k, and 24 minus 120, which is minus 96, equals 0. And we can put this straight into our calculator. So using the quadratic solver on your calculator, with coefficients 7, minus 4, and minus 96, we get that k is equal to 4, or minus 24 over 7. And from the diagram, we can see that k is positive, so we can reject this solution. So we have k is equal to 4. Okay, and now to find the area under the graph, we can use integration. So the area 1 is given by the integral from 0 to 4 of the first curve, so that is t squared over 2 plus 2 dt. And so we get, raising the power by 1 and dividing by the new power, so we get t to the power 3 over 6 and then plus 2t from 0 to 4. And evaluating this definite integral, we have 4 cubed over 6 plus 2 times 4 minus 0. And so putting this into our calculator, 4 cubed over 6 plus 2 times 4, we get 56 over 3. And for the second area, the area is given by the integral from 4 to 10 of 10 plus t over 3 minus t squared over 12 dt, and this is equal to 10t, and adding 1 to the power, t squared, and dividing by the new power, we get t squared over 6 minus t cubed over 12 times 3, that's 36, from 4 to 10. And evaluating this, we have 10 times 10, so 100, plus 100 again over 6, minus 1000 over 36, and then we have minus 40 plus 16 over 6, minus 64 over 36, subbing in 10 and 4 as t, and then putting this into your calculator, 100 plus 100 over 6 minus 1000 over 36, that gives us 800 over 9, and 40 plus 16 over 6 minus 64 over 36 gives us 368 over 9, And so we get 800 minus 368 divided by 9, which is 48. And so the total distance is these values added, so 56 over 3 plus 48, and that gives us 200 over 3 meters. That is our final answer. Okay, moving on to the next question from mixed exercise 11. Question 1. A particle starts at rest and moves in a straight line at time t seconds after the beginning of its motion. The acceleration of the particle, a meters per second, is given by a equals 3t squared minus 18t plus 20 for t is greater than or equal to 0. And we're asked to find the distance travelled by the particle in the first 5 seconds of its motion. So to do this, we can think about the velocity and we can integrate that from 0 to 5. So if we think about a velocity time graph, so velocity on the y-axis and time on the x-axis. To find the distance travelled, we always find the area underneath the curve. So if we find the velocity by integrating the acceleration, we can then find the distance travelled by integrating. So we know that velocity is equal to the integral of the acceleration with respect to time. So that is equal to the integral of 3t squared minus 18t plus 20 dt. And adding 1 to the power and dividing by the new power, we get t cubed minus 9t squared plus 20t. And don't forget to add the constant of integration. And now we're given a initial condition that the particle starts at rest. So we know that when t equals 0, v also equals 0. And so we know that 0 is equal to c, and so we can write v equals t cubed minus 9t squared plus 20t. Okay, now if we draw a graph of the velocity, so if I rub out this graph here, if we think about factorising the velocity, so we can find out its crossing points to make sure that the graph is, to make sure we account for any places where the graph might be underneath the x-axis and give us a negative area, and give us a negative value for the integral, because we're trying to find the distance. So if there are any areas of the graph which are underneath the x-axis, we need to do the two areas separately. Find the red area here first, and then find the blue area, and then add the red area to the blue area. Because if we were to just do the integral from, let's say here is b, if we were to do the integral from 0 to b of this function, then we would get the red area minus the blue area, which is not what we're looking for. So to combat this, we have to find the integral. If we call this point here a, we have to find first the integral from 0 to a of the function and add that on to the modulus of the integral from a to b of f of t dt, as we know that this here will be a negative value. Okay, so if we factorise our velocity function, we get t into t squared minus 9t plus 20, and we can factorise this even further to get t minus 4, t minus 5. And so we know that the three intersections with the x-axis will be t equals 0, t equals 4, and t equals 5. So actually we can keep this graph here. If we extend out the ends, we know that this is a positive cubic, so we'll have this sort of shape. And we know that this here is 0, this will be the point 4, and this here is a point 5. Okay, so we need to find the two integrals separately. If we first find the integral of v by itself, and then we can substitute the limits in. So the integral of v, t cubed minus 9t squared plus 20t dt is equal to t to the power 4 over 4 minus 3t to the power 3 plus 10t squared, and plus some constant of integration, which we'll call d because we've already used c up there. And because we're doing definite integrals, we don't have to worry about this constant d. So to find the red area first, we need to do the integral from 0 to 4 of t cubed minus 9t squared plus 20t. And we've worked out the integral over here, so we have this is equal to t to the power 4 over 4 minus 3t cubed plus 10t squared, evaluated from 0 to 4. And so we get 4 to the power 4 over 4 minus 3 times 4 cubed plus 10 times 4 squared. Put that into your calculator, you get 32. And doing the same for the blue integral, we have the integral from 4 to 5 of the same function, the velocity t cubed minus 9t squared plus 20t dt. That equals t to the power 4 over 4 minus 3t cubed plus 10t squared, evaluated from 4 to 5. And that equals 5 to the power 4 over 4 minus 3 times 5 cubed plus 10 times 5 squared minus 4 to the power 4 over 4 minus 3 times 4 cubed plus 10 times 4 squared. And put that into your calculator, you should get minus 3/4. And so our total distance is equal to 32 plus 3/4, and that is equal to 131 over 4 meters, and that is our final answer. And our last question, question 2. A particle travels in a straight line with an acceleration a meters per second, given by a equals 6t plus 2. The particle travels 50 meters in the 4th second. Find the velocity of the particle when t equals 5 seconds. Okay, first of all, we need to find the velocity in terms of t. So that will be equal to the integral of a dt. So that's the integral of 6t plus 2 dt, which is equal to 3t squared plus 2t plus c. And then we're told that the particle travels 50 meters in the 4th second. And if we think about what this means, the 4th second, we have a timeline. So here we have 0 seconds, here we have 1, 2, 3, 4, and so on. Here we have 5 here. This here, from 0 to 1, will be our 1st second. From 1 to 2 will be our 2nd second. From 2 to 3 will be our 3rd second. And so we can see that the 4th second will be from 3 to 4. So for the distance, we know that 50 is going to be equal to the integral from 3 to 4 of the velocity. So that is 3t squared plus 2t plus c dt. So that is equal to, so adding 1 to the power and dividing by the new power, t cubed plus t squared plus ct from 3 to 4. And plugging these values in, we get 64 plus 16 plus 4c minus 27 plus 9 plus 3c. And that'll give us, here we've got 80 and here we've got 36, so we'll have 44 plus c. And therefore c equals 6, and so our velocity is 3t squared plus 2t plus 6. And therefore the velocity when t equals 5 is equal to 3 times 5 squared plus 2 times 5 plus 6, which is equal to 75 plus 10 plus 6, which equals 91 meters per second. And that is our final answer. And that is the end of chapter 11 for Edexcel's Applied Year 1 textbook, Mechanics Part 3.